For our next vodcast, we'll be looking at properties of matter. So please have note page number 6 in front of you. Like it was discussed in the previous vodcast, matter is divided into 2 categories. Well, the same can be said for properties of matter. They can be divided into 2 categories. Those 2 categories of properties are physical properties and chemical properties. Let's focus on the physical properties first. Physical properties are constants of a particular substance. You can use our 5 senses to observe them. It does not require chemical analysis. So in the use of your 5 senses, you can help determine physical properties of particular substances, whether they're molecules, compounds, or even elements. Some examples of physical properties are the melting point of a substance, its color, its texture, to name a few. There are 2 subsets of physical properties as well. Those 2 subsets are called extensive properties and intensive properties. Even though the extensive property is listed first, let's talk about the intensive property first. In, which represents within, is a property that does not depend on how much material you are dealing with. Makes no difference the amount that you have. It helps identify the matter. It is a constant about a particular type of matter. Constant, doesn't change. So what we are looking at with intensive properties is something that doesn't change. Consistent. Oops. Throughout. An example. If you had a cup of water and 100 grams of water, or a large pot of water, it would make no difference on the amount of water you have. In order to obtain the boiling point of the water, you have to get to the same temperature of 100 degrees Celsius, or 212 degrees Fahrenheit. So the amount does not determine its intensive property. Some examples of intensive properties are its melting point, stays the same, it's consistent. Its boiling point, like we had mentioned, stays the same, is consistent. Color, density, hardness, and solubility, to name a few, for the intensive properties. Now, for the extensive properties, the EX, the X representing how much is involved. An extensive property is a property that depends on how much material you are dealing with. Some examples of extensive properties are the amount of energy a substance requires, the amount of mass that you're dealing with, the amount of heat that you're dealing with. So for extensive property, which is the opposite of intensive property, is asking yourself the question, how much mass is needed? How much heat is needed? How much energy is required? Now, further on down, if we take a look at the second part of a property of matter, let's talk about chemical properties. Chemical properties, they include behaviors of substances. How do they react when placed under certain circumstances? That adhere to when they react. Here's the key term, react with other substances. For example, reacting hydrogen with oxygen results in the combustion reaction. We'll talk about combustion reactions later on this year. They're very active when in the presence of nonmetals And if you know its particular pH, the contents of acids or bases that are involved in the solution, that helps determine chemical properties. Some other examples, if we're dealing with group 1 elements on the periodic table, and I know we really haven't spent much time, if any, talking about the periodic table, but the group 1 elements, which are the elements that are found in the first column on the periodic table, way to the left, those are considered to be your alkali metals. Those metals are highly reactive in water. But the issue here is this: if we didn't react any of these metals in water, we'd have no idea that they go through a chemical reaction. So chemical properties are something that are determined based on what you see happening. Without this interaction or the exchange of molecules, we wouldn't realize that these alkali metals or the group 1 metals are highly reactive in water. Later on this school year, we'll talk about the activity metals that are found on our periodic table, and we actually have a table within our reference table, Table J, which helps show us, without performing the experiment, if a particular metal is either slightly reactive in water or highly reactive in water. What I'd like you to do for tomorrow's class is go ahead and complete the guided practice and also come to class with any questions that you may have based on properties of matter.